I'm using a dust collector that runs on 230 volts AC, so I cannot power my dust collector directly with this switch box. Now, I could rewire it to run on 115 volts AC, but that would cause it to run less efficiently and hotter. And I still couldn't wire it directly to the switch box as it is a 2 horsepower motor and exceeds the switch box specifications. Therefore, I need to add a contactor that allows me to control the higher 230 volts AC power and current with a lower input or signal voltage of 115 volts AC that will keep me from blowing the circuit breaker on the switch box. The contactor is basically a large switch that is controlled electromagnetically. It's similar to a relay, but bigger, as this one can handle up to 600 volts at 42 amps and can be used in either single-phase or three-phase circuits. The contactor is similar to a relay, but designed to handle larger electrical loads. It's basically a large switch that's controlled electromagnetically, in this case with 120 volts from the switch box, which gets energized when my table saw or other connected tool is turned on and power draw is sensed. In order for the contactor to close, there is a magnetic coil inside that needs to be energized, and this is done by applying 120 volts AC across terminals A1 and A2, which then pulls the magnetic switch closed, allowing current to flow across the switch contacts. To make it a little easier to understand, I made this simple PowerPoint animation to explain the internal workings of the contactor. The contactor has input terminals which are labeled with an L, which stands for line, and output terminals labeled T, which stands for terminal. Each of these are bridged with a set of contacts, or sometimes called poles, like in a triple pole switch, and are designed to carry the higher 240 volts and the greater current loads without prematurely burning out. For a three-phase motor, you would use all 3 poles, but for my installation, I'm using single phase and therefore only need 2 of the poles. The contactor is normally held open by a spring, and when actuated, an armature pulls down against the spring and allows the upper contacts to connect L1 to T1, L2 to T2, and L3 to T3. The contactor incorporates a coil connected to a 120 volt AC source. Now let's look at the operation. When voltage is applied to the coil, it creates a magnetic field, since it is an electromagnet, and that pulls the armature down, which closes the contacts. When the voltage is removed from the coil, the magnetic field collapses and the spring pushes the armature back up, thereby opening the contacts. Here we apply voltage at A1 and A2, energizing the coil and pulling the armature down. Now we remove the voltage to the coil and the contactor reopens. Here it's closed and open again. Next I'll show you how I wired mine. But before I do that, let me show you a wiring schematic that I created and hope you'll find beneficial should you decide to install your own electrical contactor to control a higher horsepower motor. I'll be showing you how I wired my contactor for single phase, but it's very similar for 3-phase with the addition of just one more wire to and from the contactor. Now, let me preface by saying that even though I have many years of electrical and electronics experience, I'm not a licensed electrician, and though I'm glad to provide basic guidance with this video, any electrical work you plan to do is at your own risk. If you are planning on upgrading the electrical system on your dust collector, and you're unsure of your abilities to perform this kind of electrical work, you should first consult with a professional electrician. Okay, now that I've made my disclaimer, let's get started wiring a contactor for a dust collector motor over 1 horsepower. Here you can see the basic components for this setup: the contactor, the motor, the IVAC switch box, and single-phase 240 volt power source. We start by wiring the 240 volt plug to the contactor. You will either have a black and white or black and red wire. Hook them up to the contactor on the line side to the L1, L2, or L3 terminal lugs. It doesn't matter which one you use, and one will not be connected since we are only using single phase. If you are wiring for 3-phase, you would typically have a black, red, and white wire and attach to each of the 3 L terminals. Next, you attach the green ground wire to the grounding block on the right side of the contactor. Now attach wires to the bottom terminals of the contactor to the terminals labeled T1, T2, or T3, making sure you use the T labeled terminals that correspond to the L labeled terminals above it. Attach the other end of those wires to the motor, and then attach the green ground wire. Next, you'll install the switch box wiring. Using the provided 3-prong plug and cord, attach the black and white wires to the A1 and A2 terminal lugs. It doesn't matter which side you connect, as it is AC. Then install the green ground wire. Next, I'll show you how I wired up my contactor. I was happy that IVAC provided gland nuts for securing the cables to the contactor, but as you can see, they're far too big for the wire cables running through them. I'm not sure why they did that, as they provided the cable for the switchbox connector, and I think they should have realized the gland nut opening was too big. Now, I suppose I could have found some rubber grommets at an electrical shop, but instead I was able to use some protective cable sleeve which I had left over from another project that allowed me to take up the gap. I think I got this sleeving from Harbor Freight, but you can probably find it at your local automotive store. And it makes for a nice snug fit. Now sit back and relax to a piano instrumental piece I recently composed and performed as Brash Air as I show you how to wire the contactor.